Hello, Brad fans. How you doing? If you know me or you've listened to the show, you've probably heard me remark that bugs just happen to go about doing things, all the necessary things for life, in the grossest way possible. Need to eat some food, chew it up, digest it inside, do your business? No, bugs, why don't I spit some juices on it, digest it outside of the body, and then slurp it up through a straw like appendage? Bug sex. You've probably heard about cannibal black widow spiders. But wait, did you know that that's actually kind of a myth and that most bugs don't actually do this cannibal behavior, especially black widow spiders? And this is what we're going to talk about today: bug sex, including spiders and the other arthropods, and how some of our biases, human biases, color the way in which we research and look at this topic. We're joined by Dr. Catherine Scott, who studies black widow spiders and their reproductive strategies, and she is also featured in the upcoming documentary film titled Bug Sex, which will appear on CBC's The Nature of Things Friday, March 10th at 9 p.m. and on CBC Gem. I think there's going to be a replay on Saturdays at 3 and Sundays at 1 p.m. So Dr. Scott joined us to talk about these crazy strategies that she highlighted in the film from male black widows, and some stuff that didn't make it into the documentary. But needless to say, a big theme of what's going on is bug sex is wildly complicated. There's lots of different strategies, and even within a same species, no one individual might employ the same strategy. We often think of bugs as having these very hard, evolutionarily wired, gene's eye view kind of strategies. Just do whatever it takes to get all of your genes into the next generation, regardless if you get eaten, et cetera, et cetera, et cetera. But there's a lot more complexity going on. And again, a big theme of the conversation and of the film Bug Sex is these biases that we have. They talk about how for a long time, people only studied male behavior. There was a male bias. Most of the researchers were male back in the early 19th and 20th century, but also just our human biases in thinking about gender roles and these kind of things. Just whatever it is, we all have biases that we bring to the table. But we discuss how certain species can change these gender roles even within a season according to the different environment that they find themselves in, food availability, things like this. So it's really eye-opening to see the breadth of possibilities. And we also discuss a little bit about, what does this tell us about other species? What does this tell us about, sex in general or courtship, these kind of things? And it's not always so straightforward that you can take what we learn in one species and bring it to another, especially a distantly related species like bugs and mammals. But what it shows us is that there's a lot of factors that go into mating: environment, resource availability, the strategies of the male and the female. Bug anatomy is wild in this sense. Communication. We talked about spiders using webs to communicate and different pheromones. The point being that bugs, arthropods, make up a majority of life on the planet. So understanding how the majority of life on the planet goes about these basic functions of life is going to be useful information. And I think that that's kind of the takeaway, is that we all have to do these processes. Life is all about eating, reproducing, defend, we all do the same things. So understanding how a large majority of life does that, and especially the factors that influence how they evolve to do the things they do, is just insightful about life in general. So even if you didn't think of yourself as a bug person, as my guest Catherine Scott talks about, she hated spiders before she started researching them. This will be an interesting episode for the broader conversations about sexual strategy, sexual selection, and just how we bring our biases to science, and why it's important then to communicate science so that we can kind of get over these biases. At the very end, Dr. Scott talks about a really neat study she did looking at the misinformation that's been spread about spiders online. You may have seen this one. It garnered some headlines a little while back. So I hope you enjoy this conversation with Dr. Catherine Scott, and please do tune into the documentary on the CBC if you're in Canada or you happen to have CBC Gem, the online service. It'll be on the nature of things, the long-running CBC documentary, science documentary program, The Nature of Things, Friday, March 10th at 9 p.m., 9:30 in Newfoundland. For those of you in Canada, you'll know why that's funny. And it's titled Bug Sex. It's complicated. But of course, I have to say first, as always, please subscribe wherever you're getting the show. Leave a review, leave a comment. Follow us on Twitter and Instagram at 2brad4u. Subscribing and leaving a review is the biggest thing you can do to help out the show. You can tell a friend about it. And we would really appreciate that. Also, please feel free to get in touch with the show. As always, email 2brad4u@gmail.com, and you can message us on either of the social media apps at 2brad4u on Twitter and Instagram. Thank you so much. And you may have heard a lot about the deep fake audios going around where President Biden or President Obama or former President Trump are saying things that you never thought they would say, but it sounds really, really real. Well, that's because audio transcription is getting so good. And you know who else is really good at that? The Newsly app. The Newsly app, the all-in-one audio super app for iOS and Android, which lets you pick all of the most trending articles, curating topics and articles you want at any moment, and it will read them to you in a natural human voice. That's right. Now, I don't think they have the option yet to have Obama read you your articles, but it's a natural sounding human voice. And it just goes to show you how good this technology is getting. And Newsly has used it for not to just make some cheap, dumb jokes, but to make the entire web listenable for the first time, all in one place. Like I said, browse your articles, curate your articles, and then just have the Newsly app read them to you. We all hate reading. I say it every time I do this pitch. That's why you're listening to podcasts, right? Follow the topics you like, find your articles, get them read to you out loud. Newsly also has podcasts. You can explore trending podcasts from over 80 countries, and we're there too. We are on the features tab. If you open up the features tab on the Newsly app, you will see us. And they have digital radio. Let's not forget about digital radio. So you can download and use Newsly for free now from www.newsly.me. Newsly is spelled NEWSLY.me, or from the link that I will put in the show notes. If you use the promo code 2brad, capital TWO, capital BRAD, all one word, 2brad, that will also be in the description, you can receive a 1-month premium subscription to the Newsly app. It's a really neat service. It's a really neat idea. A lot of us don't have time to sit and read all of the articles that we do. If you look at my browser tab or my Twitter Booksmark tab, it's just filled with articles that I want to read that I mostly never get around to doing. But I always find time to listen to my podcast. So Newsly is helping with that by reading these articles to me. So I just take a slice of time when I would normally be listening to a podcast, doing the dishes, doing chores, running, something like this, exercise. You know what I'm talking about. Check out the Newsly app. You can download it for free now from www.newsly.me. All right, with that, let's get into Black Widow spiders and bug sex with Dr. Catherine Scott. So, Catherine, thank you so much for joining me today on the show. We got a lot to talk about. We have the Bug Sex movie that's going to be coming on March 10th on the CBC. You do a lot of different science communication stuff, and you do a lot of different interesting research with spiders. I wanted to start with kind of a bit of an anecdote from my career as a researcher, studying organisms that a lot of people find icky, which is, bugs and spiders are included in that. So I studied parasites, as we kind of just discussed off air. But something came up in the movie for you where you described yourself as not liking spiders and then doing research and becoming really into spiders. And I always thought the same thing. I still kind of think the same thing about parasites. I find them very fascinating. and I love talking about them and love studying them, but I simultaneously find them disgusting. And I think parasites is a little, they're internal, they're a little more, nefarious than just bugs. So I feel like bugs, spiders, we can give them a bit more leeway. We can be gentler. We don't have to call them disgusting. They play important roles. But just that dynamic of, these things are creepy crawly. They're kind of, but yet they're so fascinating. So maybe with that launching point, you can tell us about your origin story researching spiders.
Sure thing. Yeah. So I was terrified of spiders for most of my young life up until I was in university. And I only began studying them sort of through a happy coincidence or accident. So I was in a invertebrate zoology class, and the professor actually was arachnophobic. And normally there was a section on arachnids, but he ended up being sick and having to skip a class. And so he was more than happy to skip the lecture on arachnids and leave that for
Yeah,
us
how
to learn on
convenient,
our
right?
own. But I was lucky. I was lucky to have a TA in the lab named Samantha Vibert, who brought some spiders into the laboratory to show us. And at the end of the course, she sent an email around to the students advertising a summer research position, working with her on her PhD project, which was studying the vibratory communication system of black widows and hobo spiders. And up until that point, I had never really thought carefully about spiders and what they do because I found them disgusting and creepy and scary. And it had never occurred to me that spiders communicate with one another, let alone using vibrations. And so I was like, wow, that sounds really cool. And actually, in a previous life, this was my second go round with undergraduate education. I had started off as a mathematics and engineering student, so I had actually taken courses on
Hmm.
vibrations and on signals and sort of signal theory and the mathematics behind that. So I thought, oh, actually, I might have something to offer um, for this job, studying vibrations and signals. And my goal in taking these biology classes was to get into a graduate program doing research in biology. But I didn't really know what I wanted to do. I thought I maybe wanted to be a mathematical biologist because I really enjoyed math. But I thought I need experience
Hmm.
doing research in order to get into grad school. So I applied for the job, and I figured I would just have to deal with my fear if I got it. And I have a history of doing this. I was uh, taught by force to face my fears directly as a child, like when we would put up the Christmas lights in the winter. Both my dad and my older brother, whose job it normally was, are afraid of heights, and I'm terrified of heights. But as soon as they could get away with pinning the job on me and sending me up the ladder to put up the high Christmas lights, I would end up doing that. And I thought, I can deal with being on a high ladder, even though I'm afraid of heights. I can deal with working with spiders, even though I'm afraid of spiders. But I ended up getting the job. And as soon as I started thinking about spiders, looking at them closely and learning about their behavior and being in the same room with them and realizing that they're not a threat to me, I very quickly fell in love with them. And that changed the course of my life because for the over a decade now, I have been almost entirely focused on spiders and learning about their communication systems, their sexual behavior, their ecology, and I also almost immediately switched to telling everyone that I could how spiders aren't scary, they're not out to get us, they don't bite us in our sleep, and they're really important members of every ecosystem in which they occur, which is every terrestrial
Yeah,
ecosystem
yeah,
on
yeah.
Earth.
I mean, it's a cool story. I always like hearing people's origin stories when it comes to research because like everybody I talk to on this podcast that's a researcher has some kind of, it's never a clear trajectory, right, to where you are. And so I always like to hear those stories. And that's really cool that it's like, the serendipity of having studied this math field that would then apply to this is really neat. I also think it's hilarious that you
Yeah.
went from not liking spiders to going to research like black widows, which is like the scariest one, right? So-
Yes. It was sort of 0 to 100, and it was, they're the treatment for arachnophobia is
right, yeah.
exposure therapy. And so I think of this kind of as a really extreme self-imposed exposure therapy, going from being terrified of spiders to working in a room full of black widows and feeding them and handling them and that kind of thing. I also wanted to come back to your comment about you being grossed out by parasites. So as an arachnologist, I've primarily studied spiders, which is actually
Mm,
araneology. But I've also done some work with other arachnids like pseudoscorpions and
right.
ticks and mites. And I have to say, I do not love ticks. I can appreciate them. I think some of them are very beautiful, but when I get a tick on me, I freak out. I do
Yeah.
not like that. Even though I know, even working with them in the lab in a controlled environment where I knew they weren't going to bite me, I understand their biology and that I wasn't going to be harmed by them. I still am creeped out by them, and out in the world, when I'm bitten by a tick, I'm like, get
Yeah,
it off,
yeah,
get it
yeah.
off.
Well, I mean, parasites they have that extra that extra negative connotation, you know. I think, and the ticks in the wild, you got to be careful with different, Lyme disease and all these different things that you can. So we'll give you a pass on that one for sure. But I think it's cool as well that like the curiosity of something is enough to overcome that fear. Or for me too, like the disgust. Like I didn't necessarily enjoy opening up intestines and pulling out worms and stuff like that, but there was something there. And for me, it was undergraduate invertebrate zoology class as well that that sparked the interest. That it's worth it to go through. And so the spider stuff, I mean, you're talking about the communication, and we could talk about maybe let's jump to the movie and your bit in the movie, and then you told me that there's a bit that maybe got cut on the editing room floor that we can discuss. But what is it like, maybe in general terms, that you're looking at? The communication thing is fascinating to me. That there's vibrations on the webs that they're speaking with. Um, I'll throw it to you there. I just kind of threw a bunch of stuff at you, but
Yeah. So yes, my master's degree, which was at Simon Fraser University, was focused on Black widows. So I was this undergraduate assistant for Samantha, my mentor, and then, of course, I wanted to do my own project after working with her over the summer. We were focused on vibratory communication in Black widows and hobo spiders, and then I continued the work on Black widows. What Sam and I did was use a laser to measure the vibratory signals that are transmitted through the spider's web, and you'll actually see that in the film. Andrew Mason at U of T is kind of the expert
Mhm.
on this, and has done a lot of work on black widows and other spiders and how they communicate using vibrations. So that was really cool, and we were able to record the vibrations produced by males and by prey insects, and sort of understand what the male is doing to announce his presence on the web, and tell the female, I'm a male of the same species as you, not a prey item. Please don't attack me. um,
Mhm. Mhm.
so my very first job was kind of trying to decipher the vibratory language of these spiders. And then as a master's student in the same lab, I started working on their chemical communication system. So one of the things that really fascinated me about spiders and why I love them, is because they kind of challenge my human biases and the way I perceive the world, because they're so different from us. And that's one of the things that makes them scary, but it also makes them really fascinating when you start
Mhm.
to understand them better. So most web building spiders, including black widows, have extremely poor vision. So their world view, so to speak, is very different from ours. They
Mhm.
kind of can detect light and dark and shadows and movement and things like that, but they're not seeing images of the world. Their sensory world is dominated by chemicals, so their sense of smell and taste, and vibrations. And so when they are on the web, they're using vibrations to detect prey, to speak to one another. But when they're off the web, they're more or less reliant on their sense of smell. And so my master's work was trying to understand the chemical signal, the sort of personal ad that the female applies to her silk that sends an airborne message to the male that allows him to detect that there's a sexually receptive female somewhere out there and navigate towards her. And we did work on, trying to understand what the chemicals are in this signal, and also some of the male's behavior around this. So one of my favorite studies from that work was we put females in mesh cages out in the field, and so the females weren't in there. So we were isolating the web, and that's where the pheromone is actually applied onto the silk. And so we had these
Okay.
sort of pheromone traps that we put out onto the beach where we were studying black widows, that were a mesh cage with a web inside. And we waited to see, if males would arrive. And we were able to collect lots of males in that experiment. I should back up and say I also did work in the laboratory just to kind of try to understand their courtship behavior, what the male does when he arrives on the web. And he does this whole song and dance that's like literally dancing on the web, plucking strings, sending vibratory messages to the female. But then he also does this thing which is kind of strange, where he starts destroying the web. He moves around, and every once in a while he'll stop and he'll bite the silk, and he'll kind of make a hole in the web and then bundle it up and wrap it with his own silk. And in some cases, after half an hour or so, most of the web is gone and has been bundled up by the male. And the female seems to tolerate this, which is kind of weird. So I was like, okay, maybe this is a signal. Maybe the male applying his silk to the female's web is sending his own chemical signal to her, giving her information about his quality as a mate, or this kind of thing. But in the field, we compared the attractiveness of intact webs to webs that had been reduced by males, and showed that actually the function of this turns out to be that the male is shutting down the female's attractive signal so that other males can't find her.
Right. To get exclusive access, all that
Yes.
kind of stuff.
Yeah.
Okay.
So the first, it's these spiders, their mating system is such that it's very competitive. If you're a male, there's lots more males than there are females, and it's literally a race to be the first male to arrive at a female's web and mate with her. So if you're the first male to arrive, it's in your best interest to shut down that signal so other males can't find her, and then you are able to mate with her. And if you're the first male to mate, also you'll have first male sperm precedence. So the female will use your sperm first, and you also have the opportunity to deposit a mating plug. So these spiders have these long corkscrew-shaped intromittent organs that they insert into the female's genital tract, and they're able to break off the tip. And if they break it off in just the right location, it will block access to subsequently mating males. So there's all these different levels of competition. Like first there's the race to be there first, and then there's sperm competition inside the female's genital tract. But later on, when I was doing my PhD work, with Marianne Andrade at U of T, I wanted to continue studying these spiders because I found their mating system and their communication so fascinating. In that work, we ended up finding out that males can overcome the sort of that first male shutting down the female's signal, making her harder to find. Turns out males have a way around that. So this race to find females is really fun to observe. And we actually did an experiment that we called the Great Black Widow Race during my PhD. My partner was my field assistant, and we spent a lot of long nights out on the beach racing spiders. So this involved those same mesh cages with females inside, put out in a row as the finish line for the race course. So these are
Hmm.
pheromone emitting cages. And then we had a whole whack of male black widows that we had collected in advance, and we weighed them in on a tiny little scale, and we painted them with individual racing stripes and measured them so that we knew how big they were, and so that we could follow each individual male and record his time in the race, because we wanted to
Right.
know, what traits and tactics make a male a winner in the race to find females. And
Right.
so for this experiment, we had these teams of males that we released at 10-meter intervals along this race course that was set up so that the finish line was at one end. We knew that the wind was forecast to blow in a certain direction, and so then we were releasing the males upwind of the females so that they would be able to travel towards them
Right.
and navigate based on detecting her pheromones. And we found in that experiment that males were able to detect females from really incredible distances, up to 60 meters away, which, if you consider this male black widow spider is maybe a centimeter long, that's a really long distance.
Yeah.
For a If you scaled up to human size, that would be like smelling a another human um, kilometers away. So they have a very, very uh, finely tuned sense of smell for detecting a potential mate. And so during the race, they all ran down the beach towards these signaling females, and we were able to record their speeds and learn that what was it? Larger males were better at surviving and actually finishing the race, but smaller males were faster. So
Mm.
there's kind of a trade-off there, and
Trade
maybe
off. Yeah.
intermediate males end up being the most successful. But the really strange thing we found was that the males who we released farthest away from the females, and we released them all at approximately the same time, ended up finding the females fastest. They ended up, having the overall fastest race times, and that wasn't something we predicted. There wasn't an obvious reason why that should be. But when
Right.
we looked closer at the behavior of these spiders as they're moving around searching for females, we noticed that when a male is searching for a mate, what he'll do is he'll kind of wander along on the ground, and then he'll bump into a grass stem or some other vegetation, and he'll climb up it. And then when he gets to the top, he pauses and he waves his first pair of legs in the air. And if you're familiar with the idea of a questing tick, it's
Hmm.
very similar behavior. He's got sensory organs on the ends of his legs that detect chemicals. And so he's waving his legs in the air slowly and kind of rotating his body and tasting the air and getting his bearings, getting a read on where that female signal is coming from. And once he's kind of figured out where she is, he then climbs back down and moves in that direction. And then periodically he'll climb back up vegetation again,
Make
reorient,
sure he's
and
going in
so
the
on.
right. Yeah.
Exactly. And when he's doing this, spiders are constantly producing dragline silk. They leave this trail of silk behind them as a safety line. So as he climbs up the plant, he'll anchor his silk at the top, and then he'll climb down. And when he climbs up the plant, leave a bridge of silk behind him. And so this will essentially create a path from where he was to where he ends up at the female's web. And we notice that when another male is wandering around trying to find a female, if he encounters the silk trail of another male, he doesn't bother with stopping and, getting his bearings and figuring out where to go next. He just runs along the silk of that previous male. And so he's taking advantage of the fact that that first male has already done the work of finding
Right.
the female, and he just runs along that line as fast as he can towards the female. And we did some experiments to show that he's able to recognize that, yes, this is the silk of a male of the same species as me. So this is relevant information to me that is very likely going to lead me to a female quickly. And so then
Right.
he's able to sort of use that to catch up. And that was the reason in our big race that the males that were farthest away ended up being fastest, because they were more likely to encounter the silk trails of all the males who had started the race closer to the female and then just
Right.
run along these silk highways.
Yeah.
So
Yeah.
that was one of the things that didn't actually make it into the film. We ended
Yeah.
up talking more about sort of the mechanics of sex, and there is some cool footage of the males doing that orientation thing and about their chemical
Hmm.
communication. But yeah, that was definitely one of my favorite experiments to do, the Black Widow race.
Yeah, I mean, I love it because I mean, I did field work too with ants and painting ants and watching where they go, and so like, so I appreciate the meticulous nature of that and how fun it can actually be.
Yes, it
Get
can
to spend
also
your
be
summers outside.
heartbreaking. Oh my gosh.
Yeah,
So that those results I just talked about were a success, but there were a couple other times where we went to all the effort of collecting the spiders and weighing them and measuring them and painting them, and we released 100 spiders and we recaptured zero because there was
yeah.
no wind that night.
They just took off. Yeah,
Yeah.
yeah. This is also really interesting because you talked about like, and this is what's fascinating for me too, like having studied evolution and stuff too, is like the different areas that selection acts on. There's the sperm competition, and the whole like breaking off of the parts into the to block, like, I mean, there's a number of different species and insects that have these male plugs, right?
Yeah.
And then this, but then also this, the race, so
Hmm.
the I always think of it, it was termed one time in my biology class like the evolution of cheaters,
Sure.
right? Like, and when you think about it, like almost like a competition and stuff, there's
Yeah.
obviously a lot more going on, but that's really fascinating. This evolution of cheaters. Presumably, the spider, he races along the web, the male's web. He's going to have to overtake them at some point, right? If he still wants to be first, so he's got to get there, catch up, and then overtake them.
Yeah,
Is
I
there?
mean,
Do they
well, he
fight
doesn't
or?
necessarily, yeah, so yes, that's exactly what's going to happen. So he may not overtake him before they reach the female's web, but even if that male who left the trail behind arrives first, that doesn't mean he's going to mate first
Mm,
because courtship takes a long time. It's very
right.
elaborate. There's a
You
lot of
mentioned this dance, and
yes.
yeah.
And in the laboratory, it can be relatively quick, but we usually have the heat cranked up pretty high in the lab. And that was another thing that I realized in the field. Initially, I thought I was going to observe courtship in the field. It's like watching paint dry because when the temperature is like 10 degrees Celsius, arthropods, which are ectotherms, are very, very slow. And so everything is speeded up in the lab when you've got the temperature on high. In the field, I think it probably takes hours and hours and hours for the male to do his courtship and convince the female to mate with him. So that gives the second male time to catch up, and then absolutely they will fight on the web, and it can be quite aggressive. Sometimes males lose legs,
Hmm.
and then also, just because the male has arrived on the web doesn't mean he's going to convince the female to mate with him. She could still reject him. She could
Right.
eat him before he gets a chance to attempt to mate, or she could just not be interested, take a really long time, allow him to dance on the web for hours and hours, which could give other males a chance to catch up and arrive on the web and end up being the first to mate.
Yeah, end up being more suitable. Because that's kind of interesting then, because it's like you think of like, where are you going to invest your time and resources, right? So it actually seems like it's more beneficial, or it's a better bet to race to, to do this cheating sort of, whatever we want to call
Hmm.
it, behavior of just following someone who's already done the work and then hoping that you can outcompete them at the moment,
Yes,
rather than
yeah,
trying to
and
find like a totally naive, web with no other males. It's kind of counterintuitive.
yeah, that there's so much competition. There's so few receptive females and so many males that you're going to probably encounter competition no matter what. So speed is really valuable, but there are different strategies and tactics that males can use to be successful. So, and it might depend on that individual male's phenotype. So, what he looks like, what his characteristics are. Because
Hmm.
if you're a big male who is better at surviving long distance searching, and maybe you're not as fast, but you're going to have an advantage in combat with other
And
males.
fighting,
And
yeah.
females also tend to like larger males.
Okay.
So there's again trade-offs, right? Maybe you're not as fast, but you're more likely to survive the journey, which is the name of the game. Doesn't, if you're fast but you
Yeah.
die, then there's no point. And you're going to be more successful in direct competition with rival males and maybe with convincing the female to mate. If you're a small male, maybe you don't have much fighting ability, but you can be fast and you can try to race to find a female, take advantage of those silk trails, even though there's going to be another male on that web when you get there. Small males also have a cheating tactic called sneaking, where they can, the first male, this is another example of sort of parasitizing the effort of a rival male.
Hmm.
So that first male might have arrived and put a lot of time and energy into courting and doing vibrations, um, putting silk on the web, all of these things. And then a smaller male, in some cases, can just swoop in and walk right up to the female and mate with her without bothering to do any of that courtship stuff. She may or may not accept him, but if the bigger male has kind of already put her into a state where she's like, oh, that I like this. This male has
Yeah.
courted me enough that I'm going to become receptive. They enter a kind of trance-like quiescent state when they're ready to mate,
Hmm.
where they aren't as likely to sort of move around and kick the male off. So yeah, so that those smaller males might be able to sneak copulations. Once they've copulated, it still might not be sort of a slam dunk strategy, because the female might not let him copulate as long. She might not let him place a sperm plug. She might only let him copulate once rather than twice and sort of fill only
Hmm.
one sperm storage organ. So again, it's like there's pros and cons of these different strategies for being a male, being big, being small, following other males, trying to find a female that other males haven't found yet, and so on. It's all very complicated.
Yeah. And I mean, it's really interesting because you think about all the different, we always think about evolution, right, as like trade-offs, right? So there's all these different trade-offs to the different strategies. And this is why you have all these different strategies, right? Because sometimes it works. Like it works enough, each one works enough that it's continued in the population, in the lineage, right? But I wonder,
Right.
just like, this is maybe a bit too much of an extrapolation kind of thing, but studying this kind of stuff, these sort of sexual pressures, sexual selection and stuff like that, um, what is there some kind of broad takeaways you can get from, because people will always, cynical people will always ask, well, who cares, right? It's spiders, who cares, right? But is there kind of like a larger thing you can say about, mating and mate choice and stuff like this that maybe, you make, or it's a tough one.
Yeah, that's a good question. People often ask me, what good is that? What I study,
Yeah.
what's the point? And for me, it's not because it has immediate benefits to humans, or applications. Although you never know, right? The basic
Hmm.
science that leads to innovations that are valuable for humans is usually not meant for that, right? Like you
It's not evident at
accidentally,
the time. Yeah.
yeah, you do the basic science, you just find out what's going on for the sake of finding it out, and then later on it might turn out that there's something useful is going to come out of that. But yeah, the for me, the reason I'm doing it is just because it's fascinating, and I think it's valuable to learn about the way the world works. And
Hmm.
I see these spiders doing these things and I want to know why, just for the sake of knowing why. um, there certainly is value in studying spiders for understanding, more broadly the evolution of sexual behavior and communication. And if we
Hmm.
only focus on animals that are like us, vertebrates, there's tons and tons of sexual selection research on birds and mammals,
Right.
particularly. But they are in the minority in terms of the biodiversity on Earth, right? Insects
Yeah.
and spiders are far more diverse and abundant. Peter Nescrecki, or no, sorry, it's not him. Is it him who called them the smaller majority?
Mm.
Like they're the majority of life on Earth.
Yeah. Yeah. Yeah.
Right? And so it's it's important to study them and realize how diverse sexual strategies are. You know, the
Hmm.
widow spiders. I study black widows in North America, which don't do this, but their relatives, the redback spiders in Australia, which Mariana Andrade is famous for studying, because they do sexual cannibalism, kind of those weird examples um, help us to they're these exceptions, these things that animals that aren't following the rules can teach us a lot. And you know, you have to spend time with very obscure animals that are different from us to learn how diverse and weird and wonderful the world really is. And I talked before about how, you know, I find spiders challenge my biases as a human. You know, scientists like to think that we're very objective, but we're humans, right? And we see the
Hmm.
world with through our human eyes, and we have ideas about how things work. And so one of the things that is brought up several times in the film about bug sex is this idea that, you know, for years and years humans have assumed, you know, these are the sex roles, you know, females choose, males compete, and
Hmm.
that's the
Yeah,
way it
right.
is, right? But these views of how biology works are really colored by our human biases and our views of sex roles. And so when you spend time with the insects and spiders, you realize that sort of all bets are off. They do everything all different kinds of ways. Their sex lives are so diverse, and it's, you know, even the idea of sex roles, it's kind of it is it's you can't map it on to a binary like people want to, right?
Hmm.
Um,
Hmm.
so and just like for an example of the diversity of the ways that insects and spiders do things that are, you know, shocking to people. I you know, spiders and insects, their sex lives are, you know, far more kinky and weird than humans could ever conceive of. You know, there are plenty of arthropods where males have penis-like intromittent organs that they insert into females, but that's just one way of doing things. There are also some
Hmm.
insects where the female has a penis-like intromittent organ that she inserts into the male in order to get sperm.
Extract. Yeah.
Yeah, there are animals that don't bother with intromission at all. The female will sort of, or sorry, it's all external. So the male will deposit a spermatophore on the ground, and the female has to sort of pick it up with
Right.
her genital opening. And then, of course, some insects and arachnids don't have to bother with sex at all. They can reproduce asexually. So there's
Hmm.
incredible diversity of the ways of having sex, of communicating with one another through all of these different modalities. And I don't know if I'm doing a very good job of actually answering your question, but the point is, it's, you know, I think it's fascinating. It's worth studying to just understand how how amazing and diverse the natural world is.
Hmm. No, I think it makes sense what you said. I mean, I'm anyone that's listened to my podcast or heard me, you know, rant about this over a beer or something. Like basic research is absolutely essential, right? You never know where it's going to go. So I'm right with you that I totally agree. You know, basic research for the sake of doing it is enough, but then also that the understanding how the majority of life on the planet, like let's say the majority insects, you know, a massive group of life on the planet operates, like that just gives us a better understanding of life and our planet. And like that's good knowledge to have, right?
Absolutely. Yeah, and I was just going to say that people studying insects and, you know, the way that they look and why are they shiny like this, you know, that basic research of just understanding their morphology has led to all kinds of valuable
Yeah.
innovations. And the same thing is true of studying spider
Hmm.
silks and venoms, where, you know, the basic research of just, understanding the building blocks, what are these things? What are they made of? Why do they work? Has led to the development of drugs and medical devices and things like that. So you don't know when you start what's going to be have applications and benefits for humans, but also I agree with you. I think it's super important to fund basic research and just do this
Hmm.
curiosity driven uh, research to understand the
Hmm.
the world and why things are the way they are. And
When I think too with
yeah,
the spider stuff that you're talking about specifically, I mean, the idea, we talk about our biases and how, in the film they talk about how you don't look at most people just looked at it from the male point of view, and didn't really understand female behavior till, sort of now, all the different things you learn there. But the communication thing, animals that communicate in ways that are totally foreign to us, I think is just absolutely fascinating. And you could see, like, I can see, I'm just kind of off the top of my head, I wouldn't be surprised to one day hear some kind of application for the way you communicate through silk, like the vibration, like you can see that there might be some kind of odd application for that or the
absolutely.
pheromone
Yeah,
things. And
the ways that these things are these animals are they have evolved over millions of years, these exquisitely tuned sensory receptors that are extremely sensitive to
hmm,
vibrations, which are sounds, and chemicals. And I'm sure there are applications for that of, extremely sensitive and extremely specific uh, chemical receptors and vibratory receptors, right? And one of the limitations with spider silk so far is like there's all kinds of cool things that you could do with it, and it's an amazing material because it's incredibly strong and flexible. We still haven't figured out
hmm,
how to make it. We know what the building blocks are. We can make the ingredients. We can make the goo that is inside the spider's silk glands. So we can make all the precursors to spider silk, but the specific way that they extrude it through their spinnerets, humans haven't been able to
yeah.
replicate yet. But I'm sure it's
Yeah,
I'm sure it's coming.
it seems a matter of time. But yeah, that's one because I remember like hearing stuff, 10, 15 years ago too about how they were going to genetically alter like goats to produce the silk and it's stuff. And it's like, okay, you get it, but now what? You can't work with it. You can't, yeah, you can't spin it.
You
Yeah.
can't spin it. Yeah.
Okay. This is all really interesting. There's a couple things, that I wanted to hit, and I'll see if I remember them all. But the idea of studying the outliers too, as a way to kind of get this information or get a unique take on
Mhm.
the rest of life, right, is really fascinating to me. And you mentioned the cannibalism, the sexual cannibalism. That's an
Mhm.
outlier, but I think that most people we just assume that that's how bugs do it, right? Like you hear the stories about the praying mantis and the stuff like that. So what are maybe some other
Right.
kind of maybe misconceptions or something about spiders or insects that you find most people have?
When I tell people that I study black widows, certainly the thing that everyone knows about them is that the female eats the
Right.
male after sex. And that's the kind of the common misconception because it's actually quite rare that male black widows get eaten. So I mentioned the redback spiders. So they're widow spiders. They're close relatives of the black widows that we have in North America. There's another species called the brown widow that occurs worldwide. It's kind of an invasive species now. Um, in these two species, the male apparently actively
Mm.
sacrifices himself during copulation. So it's not that the female is attacking him. The male actually offers himself. And as he's transferring sperm, the spiders are kind of face to face in what we would consider
Yeah.
like missionary position. That's the kind of their typical mating position for widow spiders. And then as he's transferring sperm, he does a somersault and he pivots his body and puts his abdomen right in front of the female's fangs and offers himself to her. And then she starts nibbling on him as
Ugh.
he's transferring sperm. And it turns out that this is beneficial to the male because if the female snacks on him during copulation, he's able to copulate for longer and transfer more sperm and end up fathering more offspring. So that's the name of the game, is passing your genes on to future generations. So he's going to have more offspring. He's going to be more fit than a male who survives. This is counterintuitive, right? Because when we think about fitness, when you learn about natural selection, you hear about the
Mm-hmm.
survival of the fittest, which is also a misconception, right? It's about survival, but it's
Mm-hmm.
more about reproduction. If you don't
Your
reproduce,
survival means nothing.
then
Yeah.
it's game over. So you have to survive long enough to reproduce. And so these males, they have survived, they're mating, and now they're going to benefit from transferring as many sperm as they can to this female and fertilizing as many of her eggs as possible. Because after they're finished mating her, their chances of finding another female to mate with
Mm-hmm.
are essentially zero. So they're putting all of their sperm in one basket, kind of maximizing their fitness by making sure this female will use as many of their sperm as possible. Um, so yeah, so in this species, sexual selection has resulted in this seemingly, bizarre behavior. Why would a male allow himself to be killed? That's
Mm-hmm.
not good for his fitness, but it
Mm-hmm.
turns out that it is. Um, and the brown widows do this too. And the female sometimes doesn't accept. The male might do the somersault, and then she just, no, I'm not hungry, doesn't eat him. So it's not the idea that these females are like these aggressive sexual cannibals is a bit of a misconception. And then when you come back to the North American black widows, um, females sometimes males, but it's a lot rarer than
Mm-hmm.
most people assume. It's not the case that the female always eats the male after mating. It's more common that when the male first arrives on the web, if she finds him wanting, if he doesn't vibrate the web just the right way to convince her that he is a worthy mate, or if she mistakes him for a prey, or she's just really hungry, and
Yeah.
she would benefit more at
Yeah.
that
Weighing
moment
the
from a
costs.
meal than a mating. Then the male just
Mm-hmm.
might get eaten right away without any opportunity to mate. Occasionally, the female will attack the male during mating. That's extremely rare. I think I've only seen that once in the Western black widows that I study, and like in general, in over a decade of studying these animals, I've only seen sexual cannibalism a handful of times. It's quite rare, and I think the initial idea that black widows are cannibals occurred because people would do these experiments in the laboratory. They would have the female in a container, they would put the male in the container, he would do his thing, they would mate, and then the
It's
male
got
is
nowhere to
trapped
go.
in the
Yeah.
container with the female. Right. They're actually very
Yeah.
good at escaping. So, even if the female is hungry and she wants to eat the male, usually he's out of there. He's able to get away. So the work that I did in the field, I found that some males were able to visit two or three females over the course of their life and mate more than one time. So this is a different mating system from the redbacks, which are kind of like, they only have one shot. They're very unlikely to find more than one female in their life. The population I studied of these Western black widows in British Columbia, it's very dense. The females are quite closely spaced together. That makes a difference, and the males can survive and
Mm-hmm.
mate multiple times
That's
over
always
the course of
interesting
their
to
life.
me. It brings up some things about how environment, population density, all of these things play a role in the selection or the evolution of the behavior, right? Like if there's enough females around in a
Mm-hmm.
in your space, you wouldn't necessarily want to give yourself just the one shot and then try and maximize that one shot by allowing yourself to be eaten, right? So that's really interesting to me, and I think it's like, I don't know, this might be a bit of a outside the scope of our conversation, really, but it's something that I've been thinking about a lot in recent times. Is the gene's eye view of sort of evolution and stuff, or there's beginning to be a larger component group of biologists that talk about the other ways in which selection can work and get passed on and stuff. But a lot of times we think about these things, we reduce it down to this gene's eye view. maximum benefit, get as
Hmm.
much, sperm into the next generation, whatever, things like this. And I wonder if we have a bit of a bias when we look at insects in this way, because they tend to, like, that tends to be what you see first, right? Is these like very dramatic and kind of stark, gotta get it, I'm gonna get eaten, but it's okay, that kind of thing. You kind of
Yeah.
see where I'm going there?
And I think, yeah, and you bring up a good point about the environment, and the effect that it has on the sort of behaviors and tactics that are going to be successful. Because it's a lot of time in, in biology class, when you're learning about selection, you will hear things about how, oh, selection
Hmm.
favors large males, because they're able to survive better
Stronger, yeah, yeah.
or fight better, or whatever the case may be. But that could be context dependent. And it's so much more complicated than that. And I want to mention Daryl Gwynn, who's in the film, in the segment about dance flies, which
Hmm.
is really awesome because they're an example of these sex role reversed insects that are the opposite of the way that we
Hmm.
think is typical. Of course, what we think is typical is, based on what we choose to study and our preconceptions of what's normal, so to speak. But he actually studied these really cool insects, that are, and I'm not going to say the species because I'll get it wrong, but an insect that is typically, um, has typical sex roles. So males compete for females. But over the course of a season, he found that though that could be reversed, and you could get females competing for males, depending on the environment, depending on the availability of food, because this is a species where the male gives the
Hmm.
female a nuptial gift. And so if there's if the situation is such that females are not getting enough food, they end up starting to compete for males in order to get these nutrient-rich nuptial gifts, rather than the males competing for females. And over the course of a season, and over the course of, or over the landscape, depending on the density of food, depending on the density of males and females, you get this complete switch in sex roles in the exact
Hmm.
same population of insects even. So it's like they're actually very flexible. This idea that this phenotype is best because, in at all times, in all situations, is way too rigid way of
Hmm.
looking at things. And yeah, there's so much to learn from looking at the variation. And that's another thing that, as biologists, I all of the stuff I've done has been on a single population
Right.
of black widows, at a single place. And they might not be typical
Yeah.
of the species, because the density, the local environment might actually be weird relative to other populations. And so it's way more complicated than it at first appears.
Hmm.
And there's always going to be way more wrinkles to discover, and it's not as simple as you read in
Yeah, well,
your
and I
in
think
your
that's important.
textbooks.
So we could move now to, like, I kind of thought we would get to here earlier, but I'm really enjoying the conversation, to sort of the science communication bit, because it's like we talk about,
Hmm.
all these misconceptions that people have, and even biologists have, right? Like you said, we're all human, right? But you think about how evolution works and this sort of gene's eye view, or people are like, well, they evolved to be this, it was selected for this, so therefore it's good, right? But it's context dependent. Like there's a lot of stuff going on.
Hmm.
So in talking about science communication, one of the things that I think about, and that I've talked with other people about, is trying to embrace that gray area and communicate that as, the interesting thing. But it's difficult because so many people, I think, when they go to do science communication, they're scientists, they don't want to sound wrong. They don't want to sound, you know, like they don't know what they're talking about, or that we haven't got it all figured out. But it creates this weird, expectation, I think, for people outside of science, because then you get the flip side of that, where people are like, evolution is just a theory. It's like, yeah, well, kind of, but so it's like, how do you go about, do you think about that, and how do you go about, like, embracing the messiness of it, I guess, or the gray area.
Definitely. Yeah. So this is the major challenge of science communication is having a message that is clear, but also not overstating what you know. And I worry about this a lot because there's always caveats, there's always exceptions. And when you're doing an interview, a science journalist wants a quick sound bite, or you're trying to, fit a message into a single tweet or something, it's really hard to get all the nuance. And if if you spend too much time on the caveats, then it
Dilutes
kind
the
of takes
message. Yeah.
away
Yeah.
from your main message, right? It's a big challenge, and I can't say that I've got it figured out, but I try to have a balance, and not to overstate things, but to try to focus on a main take home message that is true. But I do think it's a problem that people want. They want a
Hmm.
firm answer, and even like the way that communication is, even in science textbooks and things, I think we end up making statements. And I think students will be familiar with this. They'll learn something in high school biology, and then if they go on to university, in their first year university class, the instructor might be like, oh yeah, well, that was an oversimplification. What you learned in
Yeah.
high school wasn't really true. It's actually this. And then if you go on later into more specific classes, I'll be like, yeah, what you learned in high school or in first year was an oversimplification. It's actually more complicated than that. So we have this tendency to try to simplify things to make them clear, but then we're losing the nuance. We're losing the interesting
Hmm.
outliers that you were talking about before. So yeah, I don't know what the answer is, but it is really important to be careful with the way that you're
Hmm.
communicating science. And I think, yeah, not to imply that this is the answer, because anytime that I'm talking to a journalist, it's usually because an interesting paper has just come out, and that's one study at one time. And next year I might have found something out that challenges that,
Hmm.
that
Hmm.
complicates it, right? Like, and that's the thing. I think the problem is the idea that science is something that has a that you can complete, that you can say,
Yeah.
okay, I've figured it out.
Yeah.
We've never figured it out. There's always more to
Yeah.
learn, right? And so I think that's maybe the popular misconception, is that, like, oh, if it's in the textbook, then we know it's kind of done, and it's never done. I think that's maybe the most important message to get across, is that science is a process, and we're constantly learning new things and updating our
Yeah.
understanding of the
It's
world.
a, it's an interest. It's, I mean, makes a lot of sense, right? And it feels like it feels like that should be more widely known, but I understand why people, especially when it comes to,
Hmm.
the stuff that we've seen with COVID and whatnot, like when your health is involved, your family's health is involved, like people want that answer, right? And a lot of times you can give that answer
Yes.
with good confidence, right? But there's always still, right? Like there's always like the
Hmm.
rare circumstances and stuff like that. But I always think about,
Yeah. And then things get updated. Like the next,
yeah,
we know more, and now we have to change our understanding of things
yeah,
because we have a better understanding of how this thing works. And then people are upset because they're like,
yeah.
"Oh, well, were they lying to us before?" Like, no, it was we were doing the best we could with the information we had,
Right.
but we're
Which
constantly getting
anyone
more
does in their
information.
normal life. If you ever like you wouldn't be a functional
Yeah,
adult human being if you still believed everything that you. But anyway, I just wondered, like,
right.
I feel like in a way, for me trying to highlight the uncertainty and the unknowns, as because that's really why most researchers do research, right? Is for those, those, that's where all the interesting stuff is when you don't know, you're like the
For
tip of the
sure.
spear of knowledge. I think I've said that a million times on this podcast. But yeah, so I don't know, it's just, how do you find ways to tell stories that highlight that too, right? Like it's good to have a settled nice story about something that you found, but I feel like, doing stories about this, what we don't know, is
Yeah.
is is also really cool.
Right. Well, and also, you know, when I try to get this across to my students, either if I'm mentoring research students or when I've taught classes in biology, is that answering a question for me, you know, you might observe something, you think, oh, that's really cool, and then you develop a hypothesis, and then you test that hypothesis. Most of the time, um, the answer that you get actually produces several more
Hmm.
questions than you started with, right? So it's like you've learned one thing, but actually now I have a whole bunch more questions because maybe it wasn't exactly what I thought was going to happen, and I noticed some things across along the way that I wasn't expecting, and now I have a whole bunch more new hypotheses to test. So even, you know, every time we sort of quote unquote finish a research project and get it published, at the end of that, there's usually at least the implication, if not explicitly stated, you know, now we need to look at
Hmm.
A, B, C, and D to figure out
Yeah.
why this happened. It's never done. We never have all the answers, and there's always, I feel like it's your science is successful when at the end of it
Hmm.
you have more questions
Yeah.
to follow up on.
I agreed. I can't add anything more there. Okay, so I've had you for about an hour now, so we can kind of wrap it up now. There was a few other things I wanted to get to, but we can save it for another time, I guess, or we can link it to in the show notes because you have a blog, Spider Bites. You're on
Mhm.
Twitter, I believe. Twitter.
Catarrhenia, yep.
Okay, yeah, we'll put all that in there too. But yeah, people can follow that because one of the cool the SciComm things you did too was the piece about the misconceptions and the media reporting on spiders, which I found really
Hmm.
interesting. If you have time and you want to give us a brief of that.
Yeah, I can just talk a little bit about that. So recently some colleagues and I did a paper about the spread of misinformation about spiders on the internet. And this kind of started as a pandemic project. The lead author, Stefano Momola, had done a previous smaller version of this study in Italy, where he's from, looking at how well the media does portraying spiders in news stories. And this is the thing that I've been interested in for a long time. And if you follow me on Twitter, not as often anymore, but I used to spend quite a lot of time, or people would send me articles about spiders, and then I would debunk them
Right.
because um, very often the articles that people would send me about spiders would be wrong. They would contain incorrect information, or they would be majorly overblown or sensationalized. Often stories about spider bites
Hmm.
contain no evidence whatsoever that there was a spider involved. And so this makes me and my colleagues in arachnology really frustrated. And so we decided to do a global study to understand how good the reporting about spiders is and what influences that.
Hmm.
And we thought that this would also be a good opportunity to sort of understand, using spiders as a case study, sort of some things about how information spreads more generally. And what we found was basically, unsurprisingly to us, there is a lot of bad reporting on spiders. About 50% of the news articles contain errors, and a large proportion of them are sensationalized. And so that wasn't surprising. But when we looked at what was driving these things, we scored each article on whether or not they had included an image and other variables. But one of the key things we looked at was whether the journalist quoted an expert in the article.
Hmm.
And that expert could be a medical professional, it could be a pest control person, or a spider expert, like an actual arachnologist who has expertise in this area. And there was no effect of medical professionals or other experts on errors or sensationalism, but there was a really strong effect of speaking to arachnologists. So when stories quoted arachnologists, they were less sensationalized, and they were more accurate. That's probably not surprising,
Hmm.
but for me, this was the most encouraging part of the study because it means, as an arachnologist, if I take the time to speak to a journalist, they're more likely to end up writing a story that's accurate and not sensationalized. And the other part of this that we learned was that the sensationalism is what drives the global spread of information. You know, a story is published in one place locally, and then it gets picked up all around the world. That's more likely to happen when it's overly
Right.
sensationalized. And so this kind of, we have the power, as you know, if you're the local arachnologist, and we're hoping to put together kind of a database of arachnologists who are willing to talk to journalists, so that if you're a journalist in Toronto, you can see, oh, there's a list of people, you know, in Ontario who I can call, who are willing to talk to me when I'm writing a spider story. And then um, that story, you know, the information that gets out there is going to be better, and the spread of poor information is going to be stopped a little bit, or decreased.
Hmm.
So that was, I think it was a fun study to do. We had over 80 co-authors from all around the world. We analyzed the news in different languages, and yeah, it gives me a little bit of hope that
There's a
there is
solution.
something
Yeah.
that we can do
Yeah.
about the spread of fake news. There's so much bad information about spiders on the internet, unfortunately, because people love to hate them,
Hmm.
and there are actual you know, consequences to that. It's not just that I love spiders and I think other people should love spiders. Uh, People being afraid of spiders can have really important consequences. You know, one of the more horrible ones is, you know, people have this idea that they should kill spiders with fire. It's not just a meme. People actually try to do it and end up burning their house down.
Yeah.
That's a real negative consequence of arachnophobia. People get into fender benders because they see a spider in their car and they
Yeah.
freak out. But also more generally, there's actually a really cool paper that just came out about biophobia. So this includes arachnophobia, or, you know, being afraid of insects and other creepy crawlies.
Hmm.
And there's this kind of vicious negative feedback loop that happens when you're afraid of spiders, or afraid of insects and other creepy crawlies, and then you avoid them, and then you end up avoiding nature, and then you start doing things that are counterproductive for the natural world, you know, using pesticides
Right.
when they're not necessary, and kind of this feeds back into avoiding nature more, and that has negative consequences, you know, for the health of our world's ecosystems, but also for our mental health, and things like that. So
Hmm.
there are kind of broader public health consequences to these kinds of fears. And I'll just say also, because I said the word creepy crawlies, of course, I don't think they're creepy. But going back to the title of the movie is Bug Sex, and bugs here is encompassing insects and spiders. I think I'm okay with the term bug as a catch-all
Hmm.
for terrestrial arthropods, I think, is generally what it means. So that would include insects, spiders, other arachnids, millipedes,
Yeah.
those kinds of things.
Yeah. Yeah.
And yeah,
It's a bit of an oversimplification, but I think it's a good one as
I
well.
think, yeah, as a title for a nature documentary, arthropod sex doesn't have the
Yeah.
same ring to it.
Yeah. Yeah, definitely. Well, this is great. And yeah, I love that study that it just shows that, you know, some of the mechanisms behind this. And it's once you hear it, you know, it all kind of makes sense, right? Like you can see how that would work, but to have it down, you know, in a study that you can see these mechanisms at play, I think is important. And hopefully it encourages more scientists to speak to journalists, because as someone that now does science
Yes.
journalism, getting people to talk to you is always a problem.
Yeah, and I think, I mean, I used to have this worry. I've gotten a lot more comfortable talking to journalists. I've always been afraid. I mean, I'm afraid of public speaking. I'm afraid of a lot of things, and I just do it anyway. Um, but but it's, you always have this fear of being misquoted
Hmm.
or taken out of context, and I think the benefits of speaking to journalists and getting to describe things in your own words greatly outweighs the potential costs.
Oh yeah.
Like, yeah,
Yeah.
I've been quoted in articles a couple times where, they didn't do a very good job, and they cherry picked a quote that kind of fit their narrative or whatever.
Hmm.
But the vast majority of times that I've been quoted, it's been good, and it means that I get to have some control over what is being communicated
Hmm.
about my work or about my area of study. And I think that's really important. Science journalists are experts at communicating with the public, but they're not experts on every single subject area. That would be impossible.
Right.
So I think as a scientist, I feel personally, I have an obligation, especially because I'm a publicly funded scientist and taxpayers are paying my salary essentially. I have an obligation to share my knowledge with the public, and I do sometimes do that directly. And some scientists like doing science communication, give public talks, have blogs, what have you. That's great. If you like doing that, awesome. If you don't like doing that, that's fine too. We're typically not trained in science communication, so
Hmm.
we may or may not enjoy that or be particularly good at it. But the least we can do, I think, is speak to people who are trained science communicators like you. Give them the benefit of our expertise so that they can tell the best story possible, the most accurate story possible to the public.
Hmm.
Yeah.
Yeah, makes sense. Makes sense. I'm glad you got it all on tape here now, so people can I could promote it. Yeah.
Yes.
Talk to me, please. No, this is great. It's been a great conversation. Thank you so much for doing it.
Thank you so much for having me.
Yeah, definitely. You're welcome back anytime. So I'll know who to call if I got a spider story on my desk that I need help with. So
Please do.
yeah,
Or I can connect you with someone else who's an expert on that particular area of spider biology.
great. Thanks so much.
You're welcome. Thank you.
There we go. Bug sex. It's complicated. Check out Dr. Catherine Scott on social media and at her blog, Spider Bites. All the links are in the show description. And do check out The Nature of Things, Friday, March 10th. That should be today that this episode is released at 9 p.m., 9:30 in Newfoundland, to watch the film. It was a really interesting film. I got a sneak peek of it in advance, and I really enjoyed it. It was really cool. As always, follow the show, Too Brad For You, at Too Brad For You on Twitter and Instagram, website toobradforyou.wordpress.com, and Gmail, toobradforyou@gmail.com. Subscribe, rate, review, give us a like, give us a follow. All of that really, really, really helps. Thank you to the Freak Motif for the music. Thank you to Sebastian Aboud for the logo. Links to their stuff on the website as well. Until next time, thanks everyone for listening. Bye for now.